So in our first technical session, we're going to be talking about iOS Firewall. We're going to start with some of the more basic functionalities of stateless firewall filtering in iOS. This means regular static access lists, both standard and extended. Then different variations of this, which include dynamic access lists, time-based access lists, reflexive access lists, before we get into content-based access control, and then ultimately the zone-based policy firewall. Now, specifically within the scope of this individual section, we're going to be talking about the standard and extended ACLs, time-based ACLs, and then dynamic access lists. Now, most of you probably already have a pretty good understanding about how access lists work, so most of this I'm going to go through pretty quickly. Should hopefully be a review, and then you may pick up a few minor points here and there that you hadn't been familiar with before. Now, the main difference, of course, between the standard access list and the extended access list is that a standard list is only going to be matching on the source address of traffic, where an extended access list can match on any number of fields that are in the layer 3 or layer 4 header. So things like the IP protocol number. This is when we're creating an access list saying permit OSPF any, permit EIGRP any. That's talking about the IP protocol number. Permit TCP any equal to 23, where the keyword TCP is referring to the protocol number of TCP. Now, as I showed previously in the documentation, there is a reference for this in the ASA documentation under that addresses, protocols, and ports section that can give you an idea as to what the protocol numbers are. You don't need to necessarily memorize these. But there's also another way to quickly check what are the protocol numbers by using the command line itself. Now, the topology that I'm going to be using for this section is fairly straightforward. We basically just have 3 routers that are connected in serial, and then there's a PC that's on one of the segments that we're going to use for testing some of the basic applications. So I already have basic IP addressing configured, I already have basic routing reachability, and the routers should have full IP reachability to each other. So if we take a look on router 1, and if we look at the show version, pipe include iOS, this is a 2900 that is running version 15.2t, so very new code, at least at this point, for this particular platform. And if we go into global config and look at a particular access list, let's say a numbered extended list, access list 100 for example, when we permit or deny, the first argument that the ACL is looking for here is the protocol number. So this is going to be between the immediately following the layer 3 header. It tells the device what is going to be the upper layer protocol. So is this an OSPF packet that needs to go to the OSPF process? Is it an ESP or AH packet that's going to the crypto process? But these keywords here, these are referring to the numbers. So if for some reason you needed to know the number of the protocol but you didn't know where to find it, you could simply say access list 100 permit 1 any, permit 2 any, and so on and so forth. Basically just copy this into Notepad, paste it in over and over and over, incrementing these numbers. Then when we look at the show access list, any of them that have pre-assigned keywords are going to show up. So this tells us that IP protocol number 1 is ICMP, IP protocol number 2 is IGMP for multicast group membership, 4 is an IP and IP tunnel, 6 is TCP, and so on and so forth. So if I were to say access list permit 47 and do show access list 100, 47 is our GRE tunnel. Now, we are going to be revisiting this as we go through other protocols and different configurations like GetVPN and IKEv2. Also, when we look at our things like the CapWeb tunnel that is going to be between the lightweight access point and the wireless LAN controller, there's certain protocol, basically signatures that we need to know about in order to deal with any type of data plane filter or infrastructure filter that we have in place. So this means that if I have an ACL configured for filtering ingress traffic as it comes in my gig 00 interface, I need to make sure to account for the other control plane protocols that I have in existence in the network. So either we would previously know what are the profiles of things like ESP, etc. But another quick method that we're going to be using periodically throughout this demonstration is to always end our ACLs in an explicit deny. So instead of permitting, we would deny IP any, and then to log the hits on this entry. Now, if we were to say log versus log input, the second one here, log input, is going to also show us the MAC address of the layer 2 forwarder on the interface. So if we have a shared LAN segment and we have the filter applied inbound, this would tell us not only that it came in the link and was denied, but it also would show us from what particular layer 2 neighbor the packet was received in. Now we'll see that this technique is going to be very useful when we start to configure other filters. For example, CBAC. If we were to say that this interface was inside and the opposite interface was outside, and then of course beyond router 2 we have some sort of the rest of the IP network, and if there are resources behind router 1 that we're trying to reach, let's say for example we have our ACS server that is located on router 1's LAN segment. As traffic comes in on the outside interface of router 3, unless our CBAC policy would be allowing the TCP port 49 traffic, which is going to be for ACS or for TACX, I should say more specifically, then we may be discarding these packets without knowing that that's a particular problem in the configuration. So by ending the ACLs in an explicit deny that also has the log statement, we can then check the log buffer to see are packets getting dropped, what is the particular signature of them, so what's the source destination, what's the protocol number, what are the port numbers, and then we can figure out do we need to add that as an explicit permit to our ACL entries. Now, one thing to note about this, though, this is basically for the lab purpose or for accounting purposes that we are doing this. We would not want to do this in production because why? Because anytime we log a packet on an ACL, that causes the traffic to be process switched. It would be going to the general purpose CPU. So if a number of packets, if a large number of packets are getting denied, and we're sending them to the CPU in order to generate the syslog messages, we could see that the router has very high CPU utilization and then starts to drop other legitimate traffic flows, like maybe OSPF adjacencies or BGP adjacencies or ISACAMP security associations. So you have to be very careful with this when you're doing logging in the data plane, but at least within our scope for the CCIE lab exam, should be perfectly fine to do this, and it's going to help us figure out if there are any flows that we need to permit that were denied basically because of an error in our configuration. Now, so beyond this, we know that we can match on the protocol number. We know we can match on the source and destination address. Also based on the protocol options, so essentially almost anything inside the IP header. So what are the port numbers? Is the port equal to TCP23 for Telnet? Is it not equal to port 80 TCP, which would mean not web traffic? We could also specify ranges from port 1000 to 2000 or greater than, less than. So depending on the particular version that you're working with, you're going to see some different variations as to what particular options the ACL can support. We can match on the ICMP type code. So is it an echo? Is it an echo reply? Is it time exceeded? Is it port unreachable? TCP states, we'll talk about this shortly when we get into the difference between stateless filtering and stateful filtering. So how does the router know that the traffic coming in is a return flow and not an initial flow? It's based on the TCP flag. So is this an ACK? Is this a push? Is this a reset in the TCP state fields? We could also match on any of the class of service bits, so the DSCP or the IP precedence in the terms of our QoS markings, or things like fragments. So if we wanted to maybe protect the router or the infrastructure against fragmentation attacks, we could deny packets from being fragmented at layer 3 as they're either accept an ingress or go outbound. So most of this hopefully should be self-explanatory as long as you spend some time to just go to the router and look at the context-sensitive help. So if we say here access list 100 permit IP any question mark, you'll see that this particular version is going to support more details in the layer 3 and layer 4 header than some of the previous versions will. So of course with IP we could check for fragments, the QoS. We could also match on the options, like match the specific option number. So does the option have, let's say, the timestamp field onto it? We could also say under the layer 4 header, TCP any question mark. So beyond just matching the port numbers, whether it's equal to or not equal to, we could say match on these specific bits. So is it a reset? Is it a SYN? So this would be the start of the initial session. Match the type of service. So a lot of these, you don't need to know all of the details behind the packet format for every single protocol, but make sure you do spend some time to look at what does this particular version support in terms of classification that it can do with the layer 3 access lists. So beyond this though, the main difference that we see is that the standard ACL is only matching on the source address. The extended access list is effectively matching on any arbitrary field that is in the layer 3 or layer 4 header. Now we'll see also once we go beyond this and we want to do more detailed filtering, there is a way on the router and also in the ASA to look at arbitrary fields inside the packet itself when we do things like deep packet inspection. And we could specify a custom signature that says look for IP, look for UDP, then look X amount of bits into the field and figure out is this particular string in the payload. So beyond doing regular access list filtering, we'll see that there is application-aware filtering that we can do on the router. And we'll talk about that when we get to more advanced zone firewall application filtering, ASA application filtering, and then the deep packet inspection on both the ASA and the router. So as I mentioned here with the access list logging, we can log regular log output versus the log input, where log input is going to generate also the layer 2 source address as a packet came in on the link. These are going to be generated as syslog informational messages. So if we want to log those to the console or log those to syslog or to VTY, we need to make sure that we're logging at the proper level. But again, the disadvantage of this is that it's going to cause the packets to be process switched. Now this also means is that we'll see in certain cases if we're trying to do a debug in the data plane of the router, normally the router only allows traffic that is process switched to be debugged. So if something is coming in one interface and exiting out and we want to see a debug output for it, we can use the ACL log with a permit in order to allow the traffic flow through, but to punt it to the CPU, and that would allow us to be able to do a debug for it. So let's say, for example, that we're trying to track down some problem where we have an IPsec VPN that is supposed to go from the test PC to some other device in the IP cloud behind router 2. And we want to figure out, is the problem on router 3 or router 2 or beyond? We could go to router 3, put an inbound ACL on this interface that permits the particular traffic flow, that says, for example, permit ESP any log, which would then cause this to be process switched, and then we could debug IP packet detail and look at the ESP communication. Or if we said permit UDP, that is any equal to 500, which is going to be for our ISACAMP, that would be one way that we can track down problems from a verification and troubleshooting process in the data plane. But again, we'll look at this in more detail once we start to add these additional applications. But the key is that the router can only debug or verify the process switch traffic by default. And by adding the log keyword on the ACL, we force the traffic to be process switched, which could be used not only just for logging, but to help us generate debugs for transit traffic. Now, when we do this logging within the scope of the exam, this probably doesn't matter because there's no actual data plane traffic that's going through. But if you were to apply these type of logs in a real design, you want to make sure that the router is not logging one message per hit on the ACL. And this is what the ACL logging of rate limiting, or rate limit logging I should say, where we could specify how often does the router generate the logs and how many particular hits on an ACL entry need to occur before the router generates the logs. So we could think of this as kind of like a summarization for the logging information, that the router is not going to generate its individual log messages on a per packet basis. Now, within the scope of the exam, again, this is probably not going to be an issue because there's not much data plane traffic that's going through. But you do need to take into account that the logging process is very high priority on the CPU. So if we were logging or debugging and we look at the show proc CPU and we see that the utilization is high, it's possible that you would not be able to access the exec process, which is actually making the CLI changes in order to say undebug all, or in order to say things like no logging on. So it might be a good idea that when you are specifying the logging level, that we log to the console, not at informational, which is where the logs for the ACL hits are going to go. But if informational is number 6, if we were to log the console at level 5, then log to the buffer at level 7, which is everything, debug messages and below. This means that the ACL hits don't go to the console, they go to just the buffer, and then you're less likely to overrun the console line and then knock yourself out of the exec process. Because now, of course, in production, this is definitely an issue because if you lock yourself out, you can't change the config. But within the lab exam, if you lock yourself out of the CLI, you're going to have to get the proctor involved in order to reboot the box or power cycle it in order to do possibly password recovery as well. So you definitely want to avoid that situation. So logging with the ACLs is fine. Most of the time, it's not going to generate tons of traffic. But in the case that it is generating a bunch of flows, you can just send that to the buffer. Then when we want to verify it from that point out, we can just show log and look at the result of this in the logging buffer. Okay, so as I mentioned, we can also rate limit these logs. We could specify the interval or the threshold. The threshold says how many hits need to go on the ACL before the log message is generated. We could also say for syslog correlation, if we're looking at this on our syslog server, to give it either basically an arbitrary string or a particular hash for the ACL. This is going to be used to basically allow us to search through the log messages once they get dropped off on syslog. So if I don't have a way to sort based on the source address of who did the log, I may want to say that the logging, actually that's on the end of the ACL. So if we say accessless 100 permit TCP any equal to 80 log question mark, we can specify essentially this arbitrary string that now gets included with the log message, that we can use that to help parse the through the syslog messages. So again, a lot of this is self-explanatory. Hopefully, once you just spend some time on the command line and look at the question mark, see what are the options under the ACL. Also, this would be not only the accessless command, but the IP accessless command. Specify what's the log update threshold, what is the logging interval, that's for the rate limit. So how many milliseconds between generating log hits. We could also say, another very useful feature here is if we wanted to resequence an ACL. So let's say we have an ACL that's getting out of control, it's got hundreds of lines, and they've been added not with proper line numbers, let's say, that makes it difficult to edit. So if we look at the show access list, we can see right now that this list is properly numbered because we were constantly just adding entries onto the end of it. But if I were to come in and let's say IP access list extended 100, so we want to edit the list, and I'll say sequence number 15 says to permit TCP any equal to 10. Sequence 16 says TCP any equal to 11. So any arbitrary entries, and we look at the show access list. If we need to add more entries between them, let's see, we need to add an entry between 15 and 16, we don't have any space anymore. So we could now say globally, we want the access list to be resequenced. The name or number in this case is 100. Let's start at sequence number 10 and increment by 50s. So now when we show access list, you can see the router just on the back end goes and edits the line numbers for you. Now the advantage of doing this versus just copying the ACL out and then pasting it back in is we don't need to remove it from the interface and then reapply it. So it's a non-disruptive change in order to renumber the ACL, where pulling the list off and then reapplying a different one, that could be disruptive depending on the individual environment. Now, as we progress throughout the class and start to get into more details for a lot of these topics, we'll get into more details about where these ACLs are going to be applied. Now, of course, that we know in the data plane, if we're applying the access list as a traffic filter, at the interface, this is going to be the IP access group command. We could also use it for traffic classification inside the modular quality of service, or inside the zone-based firewall, or inside deep packet inspection. This would be to match the access group under a class map, which we'll come back to that and talk about that in much more detail later. If we wanted to use this as a filter for the routing control plane, we could reference the ACL from a distribute list or a route map to say, I don't want to advertise network 10 out this particular interface, or I don't want to receive host routes in this particular link. Another option would be to apply it to the VTY lines or even the console to control who can come in or out the line. So who can telnet into the router, if you're connected to the router, who can telnet out to other devices, or who can SSH out to other devices. This we're going to come back to and talk about in more detail later when we get to AAA. And we talk about things like role-based access control, TACX and radius, accounting authorization, authentication, authorization, and accounting. And then also more details in infrastructure hardening, things like control plane policing, control plane protection, that are going to be used to make sure that the router itself or the switch itself is not a victim of some type of denial of service attack or some type of exploit. Now, from a documentation point of view, if you did need to reference any of these particular commands, if we go to the main documentation, and from products to iOS, regular iOS, 15, let's say 3T, configuration guides. This would be considered securing the data plane, because it's an inline data plane filter, configuring access control lists. So make sure you do spend some time to read through the documentation, essentially for all of these sections. There's no shortcut for this. You do need to spend the time to read through the documentation so you know what features are available and what the router can or cannot do in that particular version. Now, in the 15.2 and 15.3 documentation, you'll also notice here that the IPv6 guides have now been rolled together with IPv4. So there's not a separate section anymore that says just for IP version 6, because there's starting to be more close feature parity between version 4 and version 6 in iOS. So they don't have a separate EdgeRPv6 documentation section. It's going to be just under IP routing. Now, IPv6, we're going to come back and talk about it as a separate, on its own security section, because a lot of the v4 filtering and firewall features are going to be rolled over into IPv6, and there's only very minor changes that we need to make in order to make them version 6 aware. So we'll come back to that later in class once we've gone through all the IP version 4 counterparts first. But we can see here the main documentation would be under Access Control List Overview and Guidelines. And then some of these more specific features, like I mentioned, the syslog correlation. This would be that cookie, that string that you're adding onto to the end of the ACLs. Also in this version, there is now object group support for ACLs in regular iOS, as in addition to ASA, where if we look at basically their example here, instead of referencing the host address, so this would be a /32, or the particular range of addresses as individual ACEs, so access control entries in the ACL, we're putting them together in a group and then referencing the group from the particular access list. Now, one of the disadvantages here of doing this, though, is if we were to do something on router 1, like let's say object group is a network group for denied attackers. And we specified that the attackers are 1, 2, 3, 4, and 5, 6, 7, 8, and 9, 10, 11, 12. Okay, so these are some source addresses that we want to drop. Then in our access list, let's say IP access list extended outside in, we're going to deny the object group that is denied attackers. Object group mismatch. I need to say object group deny IP object group denied attackers, because this is the source address I'm trying to match, and going anywhere. Then permit IP any. Now, when we look at the show access list here, and notice that for access list outside in, it does not automatically expand the object group, similar to how it works in ASA. Or excuse me, different than how it works in ASA. And we'll talk about this in ASA when we look at its basic stateless and stateful filters. But this means that the disadvantage of using this in iOS is that you cannot do per ACE accounting if you are using an object group. So this means that if I'm getting some attack coming in and I group all the sources together in an object group, if I want to figure out which of the sources is actually doing the attack, there's no individual hits that say 1, 2, 3, 4 versus 5, 6, 7, 8. So when we look at the show object group, there's no counters that are associated with these individual hosts. So it makes the manageability of the access list a little bit better, but you lose some visibility in the accounting. Then we have the ACL IP option selective drop. This was, as I showed, when we just look at the IP question mark at the end, we can specify we could specify which particular options we want to drop, or globally. This basically says drop any packet that has any option at all set. Then this is also where we're going to find the dynamic access lists and the reflexive access lists documented, which is what we're going to talk about here next. But again, the main point being here, don't exclude the documentation, even for sections that you think that you already know. You know, I know how access lists work, I don't need to look at the documentation. The key is that you need to make sure you know what are some of the newer features that are available, because if they were to ask you this in the exam, let's say IP options drop, if you didn't even know that that was a feature to begin with, that's what's going to be problematic. That you won't have enough time in the exam to sort through the documentation and figure out, well, what are they even asking me in the first place, and then what's the particular syntax that would be needed in order to implement this. Okay, another interesting application of the access list is going to be time-based. Now, what's interesting about this is that with the time-based ACL, we're not limited as to what the ACL is actually used for. So, as you could probably guess, even if you've never seen this feature before, the ACL entry is going to be activated based on the router's clock, where we could say, for example, I want from 9 a.m. to 5 p.m. on Monday, January, whatever, the particular year. This would be an absolute time. We could also say periodically, like every Monday through Friday, 9 a.m. to 5 p.m., I want this ACL to be activated. But the interesting thing is that you can use this for different applications other than just a traffic filter. You could do things like time-based QoS, beyond just the time-based traffic filter. Essentially, any type of access list application, you could tie the time-based ACL to it. You could do time-based route filtering, for example, if you wanted to, or say, from what time are people allowed to telnet into the router. So this is pretty straightforward in its application. The only one thing that you would need to watch out for with this is to make sure that the router's clock is properly synchronized. And this is going to be done with network time protocol with NTP. NTP we'll see that is going to be an integral part of a lot of these security technologies. Anything that is certificate-based, or both the ICE server and the ACS server, if they do not have proper time, they will have some functionality issues. So in general, you do want to make sure that all the devices in the network are synchronized, that they agree on the same time. In the lab exam, either they might give you an NTP server where they say, this Windows machine runs NTP, or you need to configure one of the devices on your end, like one of the routers, as a server, and then point your internal devices to that. But we'll revisit this as we get to things like certificate-based authentication and the ACS and the ICE server as well. There's a question, is there a good resource on how the router and ASA handle the ACLs, distribute list, route maps, etc. concerning process switch versus Ceph switch and when it will punt to the CPU? Not really offhand that I can think of that is an external document. There is, actually let me search for this real quick. There was a Cisco live presentation that was like iOS architecture, I believe. There's this one here, firewall architecture. iOS routing internals. I think it's this one. Yes. Learn how iOS routers do their job. We discuss how Ceph works and how it relates to CPU and memory utilization. We take these concepts to show how they impact equal cost routing and routing fast convergence. So this talks a little bit about the switching mechanisms and what would cause things to be punted to the CPU, what would be process switch and what would be not. The other thing that is a little bit older, but it's still relevant to this, is a book that is called Inside Cisco iOS Software Architecture. And this one goes over a little bit about just the internals of iOS and how process switching works versus Ceph switching. But other than that, I can't really think of anything offhand that shows, concisely these are all the possible things that can impact what gets punted and what does not. There was a comment here, 3020 presentation speaks about the ASA architecture. I think that was the other one. Firewall architecture. No, it's not this one. It is BRK SEC-3020. Cisco Advanced Firewalls Inside and Out. This session provides a deep insight into the ASA firewall's architecture and packet path processing as guidance for troubleshooting, deploying, and maximizing system performance. So really, the key with a question like that is that it's proprietary to their implementation. So a lot of times it's very difficult to find external documentation that says this is exactly how the packet processing path works. And if this is true, you get punted. If else, you go to Ceph. So this is one of the reasons why Cisco Live 365 is such a good resource, is these are basically like the internal engineering presentations, a lot of the times by the TMEs for the particular business units that put these together and have real deep insight as to how the hardware and software architecture works, a lot more than generally you can find out by just looking at the external documentation. Now, there are some other cases we'll look at later, like when we get to attack mitigation. One thing that you can see is that if packets are getting punted to the CPU, you'll be able to tell this just by looking at the show proc CPU. So if we say show processes CPU and look at the sorted output, this will show you what are the particular processes that the router is running and which of them are causing high utilization. And we'll look at this doing some basic attacks against the router, like doing a UDP flood and then looking at what happens to the CPU. But there is a bunch of good external documentation, like troubleshooting high CPU utilization on Cisco routers. And this document here does link to a number of other documents that talks about, okay, you have high CPU utilization, look at show proc CPU, figure out which is the reason why, and then it links you to other documents like, okay, well, if it's because of interrupts, what do you do? Well, look at the document that's talking about, you know, you're getting punted to the CPU because there's this issue in Ceph, and you know, what does relate to this, what does not. But this we're going to come back to when we talk about more infrastructure security and device hardening and attack mitigation, both on iOS and ASA, which would be things like control plane policing, control plane protection, and so on and so forth. But yeah, it definitely is confusing there because there's not a lot of good documentation that clearly says this traffic will be process switched, this traffic will not. Okay, the other application we're going to look at here before getting into our stateful filters is the dynamic access list, or what was previously known as the lock and key ACLs. Now, this is pretty much, you could consider this a legacy application. There's not too many use cases for this anymore, but the original idea was that we would open a hole in an access list based on authentication information going to the router. So for example, I telnet into the outside interface of the router, I log in as username Brian with my password, and it opens up an ACL entry for me. Now the disadvantage of doing this though is that you can only have one dynamic access list per interface, which means that regardless which user authenticates, it's going to open up all of the dynamic entries that we specify. This is the reason why the feature is kind of legacy now, and it's been replaced by authentication proxy and the per user firewall, which would allow a security policy to be applied to the user either based on their authentication or based on their identity, and then download that information from either Radius or TACACS. But in the case of the dynamic access list, this is a locally significant implementation. It does not require that you use AAA in order to turn this on. So a potential application for this would be if traffic is coming from the inside network and going to the outside, we could stop the users and say that they need to authenticate before we send their traffic to the internet. Or as traffic is coming from the outside in, there's some sort of private resource that we want to access on the inside, and we don't want to do SSL VPN for whatever reason. So have the users telnet or SSH to the router, put the login information in, and then that's going to open up the hole for the particular access list entry. But again, in general, this has been replaced with authentication proxy, which is a per user ACL that we download from the AAA server, simply based on the fact that the lock and key or the dynamic ACL, you cannot specify which user is associated with which particular dynamic entry. Now, the implementation of this is a little bit strange, where we first define the access list and have an entry that is dynamic. So we say access list 100 has an ACL that says permit IP any, but it's a dynamic entry. Now, what's a little bit strange about this is that to activate the entry, to allow it to be used, we need to issue the exec command access-enable. So this means that someone is actually logging into the exec process of the router, like telnetting to the CLI and then issuing manually the access-enable command, or having the router run an auto command to issue this once the user logs in. So we need to make sure first up that the user is authorized to run this command, that they have the sufficient privilege level to issue the command in order to open the dynamic ACL entry, and that also we're not just giving them unlimited access to the CLI. So if the user telnets in at privilege level 15, and we're doing that just for the fact of them issuing the access-enable command, that's probably not the greatest idea, because then they have control over the actual configuration of the router. So we issue access-enable. We can either do this per user or per line, where we can issue an auto command under the user, or under the line issue an auto command that says once you authenticate to this line or as this user, we're automatically going to run this particular command. And again, as I mentioned, this is documented under that same section, which is the Security Configuration Guide under Access Control Lists, which is part of securing the data plane. Then down towards the bottom, this is the configuring lock and key security for dynamic access lists. Okay, so let's take a look at a basic example of this, where right now we have router 3 connected to the test PC, and let's assume that this is our inside interface. And between router 3 and router 2, we'll say that this is our outside. And our goal is that we want to limit traffic as it comes in from this test PC, and it comes in the inside and then it goes out the outside. We want to say that if the test PC wants to do regular web browsing, so if they want to use TCP/80, they're first going to have to telnet into router 3, authenticate, and then the router is going to open up the hole in the ACL in order to allow the traffic to flow through. Okay, there's a question. Let's say that I have two dynamic ACLs applied to two different interfaces. If one user authenticates, will it open both dynamic ACLs or only the one where the user logged into the router? That's a really good question. Let's take a look at that after we look at this example. So the question is, what if I have another entry that is configured in on this interface, where we say that this is ACL 13 and this is ACL 11? So if I have a dynamic entry here, does it affect the dynamic entries in the other access list? So let's look at the basic example, and then we'll look at that variation as well. So first on router 2, let's tell this that it is the web server. So router 2 is going to say IP HTTP server. So now it's listening on port 80. And if we show IP interface brief, router 2 has a loopback that is 150.1.2.2. So if we were to go to router 3, for example, and telnet to this address, telnet to 150.1.2.2 at port 80, we should get a response in. Okay, so this is the iOS web server. We can see that it's listening at port 80. Now the same should be true when we come in from the PC that's on that segment. Okay, so this is that machine. It should be able to currently reach 150.1.2.2. And if we open up our web browser and connect to it, 150.1.2.2, we should get a login box basically telling us that we want to get privilege level 15 access or privilege exec access to router 2 for management. So we can see router 2 is listening for the web service. Okay, let's also say on router 2 that we actually have a username. That globally we have the username Cisco, password Cisco. Username Cisco has a privilege level of 15. So if we log in as this user, Cisco, and actually I think that Chrome can't talk to the router's web page. Let's try this from IE. And I may need to say here on router 2, IP HTTP authentication is local. We're going to come back and talk about this later when we get into authentication proxy. But this behaves a little bit different in the newer versions. Now, maybe it's missing files on its flash. In any case, we could see that the login box comes up that router 2 is listening for that particular service. Okay, so next we're going to configure router 3 to filter traffic as it is received in on that inside interface. So specifically here, this is interface FA00.11. This is the interface that the ACL is going to be applied inbound. So on router 3, we're going to say that we have IP access list inside in, which is an extended list, that denies TCP any equal to 80, but it permits anything else. Permit IP any, and actually let's say before this, let's log these hits. Log input. Then permit IP any. We're logging to the console at level 7. And on interface F00.11, IP access group inside in is applied inbound. So if we show access list, we should see hits on this number once the server now tries to web browse to router 2 again. So if we refresh the page and look at router 3, we can see the packets are getting denied. Now again, notice here with the log input statement, the difference between a normal log is that it's also showing us who is the layer 2 forwarder on that link. So in this particular case, this is the MAC address of that virtual machine. It says in on fast Ethernet 00.11. This was the MAC address that it came from, and this is their layer 3 source. Okay, so next we're going to configure the dynamic entry. If we show access lists, the dynamic entry is going to need to go above or below the deny. Now remember, the ACL is processed on a top-down fashion. So if the dynamic permit is after the static deny, then the dynamic permit is never going to be matched. This means that your dynamic entry in general should go towards the top of the list, not towards the bottom of the list. So we're going to say here on router 3, under IP access list extended inside in, that entry number 1 is now our dynamic entry. And we'll say that this is our web filter. This is just any arbitrary name. And this dynamic entry wants to permit TCP any equal to 80. And we could also say, actually no, that's all we need. Permit TCP any equal to 80. And if we show access list, okay, we can see right now it's not getting any hits on it. So now we have the next step where we need to somehow activate this entry. Now we either could have the user log in and manually issue the access-enable command, and this is allowed for VTY connections only. So the user has to telnet in or SSH in, issue this command, and then it should open up that particular entry. So on router 3, let's say here we have the username, let's say Brian, password Cisco, and our enable password is Cisco. Under the VTY line, our login is going to be with the local database. Okay, more details about this we're going to come back to as it relates to AAA. So local authentication, authorization, accounting, etc. Okay, so now on the VM, if we telnet into router 3, where router 3 in this case is 10.1.0.3, 10.1.0.3, username Brian, password Cisco, access-enable. If we now look at router 3 and show access lists, we can see now the dynamic entry is open. From the VM, if we now try to web browse to the server, we should get the login box, which we do. So if we look at router 3, we should now have hits on that particular entry. And again, since the list is processed top-down, now the dynamic entry is active. This second deny, which is essentially the same match, which is TCP any equal to port 80, the first match is taking precedence, so once the match occurs, it exits out of the list. Now, another disadvantage of this specific design as we have it right now is that the user, again, had to telnet into router 3, get to the CLI, and then issue this command access-enable. And additionally, the dynamic entry is never going to time out now because we didn't specify an idle timer or an absolute timer either on the individual access list entry or based on the individual username. And you could see this in the documentation for that particular feature. If we go to the lock and key security, and let's just actually search on the page for timeout. There's two different timeouts here. There is either an idle timeout or an absolute timeout, where the idle timeout is going to be refreshed based on the traffic flow matching, and the absolute timer is just going to be some threshold that they could never breach. Like they have to re-authenticate every half an hour. Now, when we specify this, it can either be configured on either define an idle timeout with the timeout keyword in the access enable, or in the auto command, or define the absolute timeout value with the access list. So if you specify the timer in the ACL, that's the absolute timer. If you specify it in the access-enable command, that would be the idle timer. But the problem is now there's no way that we can delete this entry on router 3. So either we have to delete the list and reapply it, or remove it from the interface and then reapply it. So on router 3, if we look at that link where it was applied, let's say no IP access group inside and in, and reapply it. When we show access list, actually the dynamic entry is still there. Let's try, I'm not sure if we can do it in this version, but let's say clear access template, the access list name, dynamic access list name is the web filter. Source is any. Destination any. There we go. Some versions this command is there, but it doesn't actually work. But we can see now the dynamic entry was deleted. There was another one previously under number 1. This was the active instance of the dynamic entry. And now we can see it's deleted. So now, as opposed to having the user just telnet in and then issue the command access-enable like we did here, there's a couple different variations. We could say on router 3 that when the username Brian logs in, there's an auto command run. The one thing you have to remember about this is that the argument for the auto command is an arbitrary syntax. So it means that you have to know exactly what is going to come after the auto command. When you issue a question mark here, it's not going to say type access enable, because this could be something like auto command show IP route or auto command show users, where it's going to be anything that's just automatically issued into the exec process once that user authenticates. So here in our case, we need to say access-enable. And it doesn't give us any help, but we're going to say host and timeout 30. Then let's look at what happens when we telnet in again to router 3. So we telnet in, username is Brian, password is Cisco. It did not say authentication failed, but it disconnected us from the router. So if we look at router 3 and now look at the show access list, two things were changed here. Actually, two things were supposed to be changed. Only one of them actually did. The host keyword, so the host keyword in the access enable command said we're only going to put the entry from the particular source address that authenticated. And you'll see this is what they talk about in that document as a potential way to spoof the lock and key, that if you don't have this keyword on there for the host, it means once the user authenticates, anyone would be able to use the service. So previously, if we scroll up on router 3 and look at what did the ACE look like before, it was permit TCP any equal to www. So any source would be able to use port 80. But now in this case, since we issued the host command after access-enable, it says that only the source address 10.10100 is allowed to use this dynamic entry. Even though the dynamic entry itself says permit TCP any source, we're essentially overriding this by adding the host keyword as an argument to access-enable. Now it's supposed to also show the timeout value there, but this feature is a little bit buggy in different versions. Let me try to reverse these two arguments and see if that changes anything. Let's say access-enable timeout 30 for the host, and show access list. Let's clear access. Actually, that did do it. So again, since the command here doesn't give you help, it's any arbitrary command that you type in after auto command, you have to know the exact order and the exact spelling of the syntax. If it's something that is ambiguous, the router's not going to give you an error message like it normally does in the parser. Or if you type show I, it gives you an error message because it says that's not a unique command. But in this case, with auto command, it doesn't know in the parser what is supposed to come after that. It's any arbitrary thing that we want to enter. Okay, the other option would be to do this under the VTY line. We could say auto command is same thing, access-enable timeout 30 for that host. So that would just be any particular user that is telnetting in. Okay, so back to our question. Someone asked, what if we have two dynamic ACLs? So right now we have the list applied in on router 3's fast Ethernet 00.11 interface. When the user came in there, they authenticated, and then they were allowed to reach port 80 on router 2. So the question is now, what if we have multiple ACLs? What if we have a separate entry on VLAN 13 inbound? When we issue the access-enable, is it going to open all of the entries or just the one that's on that specific interface? So on router 3, let's remove the current entry, which again we could do with clear access template. Clear access template, the ACL name is inside in. The dynamic access list is web filter. Source is 10.10100. Destination is any. Okay, so that deleted the entry. Let's say we have another access list, IP access list, inside in 2. That basically says the same thing. We have a dynamic entry. We'll say that this is web filter 2 that permits TCP any equal to www. Another line that denies it. And then another line that says permit IP any. Okay, we're then going to apply this in on F00.13, which is in from router 1. IP access group, web filter 2 inbound. So we should see on router 1 that we are able to ping 150.122. We should be able to telnet there. But if we try to reach it at port 80, that should be denied, which it didn't. So I probably applied this. Let's see if I applied it on the wrong link. IP access group web filter 2 in. No, I specified the dynamic entry, not the actual ACL name. That should have been inside in 2. Now, as kind of a side note for this, whenever you are creating an access list, regardless what the application is, whether it's for stateless filtering like this, or we're using it for zone firewall or some sort of QoS configuration, do yourself a favor and make sure that you look at the show access list output first to make sure that you know that you're not overwriting a previous list that you had already defined. Now, of course, that's going to be an issue in production. If you overlap the ACLs, there's going to be some, inconsistent behavior. But if you do this in the lab exam, you're going to waste yourself a lot of time that eventually later you're going to have to come back and undo the config and redo it. So just as kind of a side note there, watch out for that you don't accidentally overlap a name that you had previously used. Another thing with this is that when an access list is applied, so let's take a look at router 3 and let's show run. this was the interface that I put the wrong list name on. So if we scroll back up, what I had said was IP access group web filter 2 in. If we show access list web filter 2, this list doesn't exist. So this means that when you apply an ACL, a non-existent ACL to the interface, it's an implicit permit. It is going to allow all traffic. Now the problem with this is that if I have this applied, then I go to create it. If I now say IP access list extended web filter 2, as soon as I issue anything, now in this case it doesn't allow me to do that because it overlaps with the dynamic entry, but let's assume it didn't have that problem. As soon as we issue one command under the ACL and configure an entry, it activates the implicit deny at the end of that list. So if that ACL is applied on the ingress interface that I'm using to manage the router, it means that I would have locked myself out. So if I'm telnetting into some remote router, I apply the ACL in before I actually configure it, it's fine. But then as soon as I issue one entry like permit TCP any equal to 80, it's going to start dropping all other traffic. So as a general rule, you always want to make sure to create the list before you apply it, and just double check the name by saying show access list before you actually do that. Okay, so let's see now on router 1, we should still be able to ping them, but not reach them at port 80, which is correct. Okay, on router 3, if we look at the show access list, we have 2 lists. Neither of them have their dynamic entries active. So let's go to the PC, and we're going to telnet to 10.103. That's router 3. Login is Brian, password Cisco. And I think I may have deleted the password when I tried to delete the auto command. This is kind of a strange config. The username is created, but it doesn't have a password associated with it. Line has invalid auto command, access enable timeout 30 host. Let's say show run include a username. Maybe it was the other way around. Let's say, for now, let's forget the timeout. Let's just say access enable host. Username Brian, password Cisco. And I deleted the password again by issuing that. Username Brian, password Cisco. Do show run include username. So again, notice here it doesn't say login invalid or authentication failed. This means that it should have run the auto command. Now on router 3, if we look at the do show access lists, it only opens the one that was for the ingress interface. So it can distinguish here between different lists on different interfaces, but the problem is it cannot distinguish between different users on the same interface. So I cannot say that user Brian is allowed to dynamically open web traffic while user Bob is dynamically able to open SSL traffic. In that particular case, you would want to use authentication proxy, or if it was the ASA, that is what the cut-through proxy feature is going to be used for. Now, the advantage of doing it this way, though, is it's only a locally significant config. We don't need to get AAA involved with Radius or TACX and then download the ACL from AAA. It's going to be whatever the local configuration that we specify here. So let's review real quick our final config. If we show run section access list or interface or username, we have the username that has the auto command to say access-enable, which again the host argument is saying when they activate the dynamic entry, put their source address as the source address in the ACL. The ACL is applied as an ingress data plane filter, so IP access group inbound. Then in the ACL itself, we're saying there is a dynamic permit followed by an identical static deny. Now you could also do these opposite. You could do leave this at the end and have this as your implicit dynamic permit. And I think that's what they do it in their particular example in the documentation. So if we look at, let's go back to the top of the lock and key document and then go to their example. So lock and key with local authentication. They're saying allow people to telnet into the router itself, because this is how they're going to activate the dynamic entry. But then after this, there is an implicit deny that goes below the dynamic statement. So this is kind of the backwards logic, which it makes their example a little bit more confusing than it needs to be. But the way that you read the ACL, you always add the deny at the end. So this is saying statically permit them to be able to telnet in. If the dynamic entry is open, they're allowed to do anything. If the dynamic entry is closed, they fall back to the implicit deny at the end. Okay, there's a question: how does the router know to activate the one connected to the interface down to the PC and not the other one? Well, when the router receives the packet in, if we look at the show users, if we were to see the user telling it in, we would know what their source address is, and we know what the ingress interface is. So if we look at show access list, this list was applied to their ingress interface. That's the reason that's the one that gets activated. So basically on the back end, it has to do with the order of operations. When the packet comes in, the router knows what is the ingress interface. So it's basically, you know, keeping that as a runtime variable. It goes through the authentication and it says, okay, whatever ACL was on that same interface, that's the one that the dynamic entry should be applied in on. Now we'll see this is kind of a similar case when we get to content-based access control, that you can have multiple users coming in from multiple interfaces, but when the return flows come back, the router automatically knows which interface it should return to because the state table is keeping that information. So basically behind the scenes, it's doing that for us, which is the association between the where the user came in, what interface the user came in on, and then what the dynamic ACL is that's applied on that particular link.